So I'll just give 2 minutes in case anybody else is joining, and then we'll start. So if you have any questions from week 4 or week 5, week 4 assignment or week 5 course content, you can type it into the chat box, or you can just unmute yourself and let me know. So I know like what questions you guys have, and I'll try to answer it.
Hello, ma'am. Good evening. Hello. Am I audible?
Yes, I can hear you. Sorry, I was
Ma'am,
muted. Yeah.
right, ma'am. This is question number 4, ma'am. This was about utility function.
Which week is this? Question 4 from?
Week 4 only, ma'am.
Week 4. Okay.
Yes.
Yes, go ahead.
Ma'am, this question only, I just wanted to know how this has to be solved. Could you please show this solving, ma'am?
Okay, I'll solve it. I think I had solved a
Yes.
similar thing in the last class, but I
Yes, ma'am.
didn't solve this exact question because your assignment
Yes,
date was
ma'am.
still
Yes,
due.
ma'am.
So, okay, I'll solve that one.
Right.
Any other questions anyone has? No? Okay. Right. So, let me just share question 4. So, this Graydon consumes only 2 goods, pineapple and honey, and his utility function is given 3 and so. Okay, firstly, I think I hope you got um, the correction in the question that it's not hamburger, it is just honey and whatever is the other pineapple. It's I think creating some kind of confusion. Just give me a minute. I haven't solved this question. Let me just read it. So you understand how you write the budget constraint, I hope. That part is not very
Yes,
complicated,
ma'am. Yes, ma'am.
right? Yeah. So what we are trying to do is first, in this actually they have given the utility function, but they're asking only the slope of the budget line. They have not asked you for anything about utility maximization. So this is the utility function that is given is kind of like a red herring. It's not really doing anything in this particular question. It's just some extra information given to you because they are asking you the slope of the budget line, and the budget line you can draw with this information where it says the price of pineapple is $3 and the price of honey is $6 and his monthly income is $300, right? So you can write the budget equation. How do you do that? We discussed this. This is like the normal way we write the budget equation or the budget constraint. Nothing very complicated. Do you remember how we write it? The budget equation? What is budget equation? Again, don't try to memorize it. Just tell me from common sense. If you're spending something on one good and something else on another good, then budget equation is nothing but summary of those two
summation of-
expenditures. Yes, some summary of expenditure on both those two items cannot exceed your total income, right? I mean, we are assuming there is no credit cards and stuff available. This is just very simple case. We're not assuming anything special here. So discounting any kind of such special scenarios, we just take P1x1, P2x2, right? So some P1x1 and P2x2 is less than or equal to your income. So in this case, we know P1 and we know P2. So what is it? It is 3. Let me just open this. Just give me a moment. I'm actually just trying to share the screen from this. Okay. Share. Okay, so you can see my screen, I hope. Week 4, question 4. We are given P1 is equal to $3, right? And P2 is equal to $6, and income is equal to $300. Is that so? Yeah. So budget constraint is nothing but P1 into what is the first good? Pineapple. Plus P2 into second good is honey is equal to 300. It's less than or equal to, but for plotting the line, we are just going to take the equality anyway. So this becomes 3P plus 6H is equal to 300. Now, what is the slope of this line? This is a line which is something like this, right? If I plot budget line, let's assume P is here and H is here. So this is, I think it's a little bit of an assumption you will need to make, just basis the fact that it's given utility P with respect to H, meaning you can assume P is plotted on the horizontal axis, H is on the vertical axis. So P for H is equal to 0, P is what? 100. So say suppose this is 100. For H is equal, P is equal to 0, H is equal to 50 something. Say suppose this is 50. So this is your budget line, right? So now you can calculate the slope of this line. It will come out to be it will come out to be minus half. It's downward sloping, so it's going to be negative, and you can see, minus 50 by 100 you can take, or whichever way you want to calculate it. Is it clear? Does that answer your question?
Okay, thank you. Right.
Yep. So it's not a very difficult question. It just became a bit confusing, I think, because they gave the utility relation and stuff. But I think maybe just one takeaway you can take from the utility function is that you need to plot P on the horizontal axis and H on the vertical axis. Otherwise, I mean, left to you, you can plot it any which way you like, right? But they've not specified it anywhere of what with respect to what in the budget constraint. So we can just take it as P comma H, as in P on horizontal and H on vertical axis. And the negative implies that it is downward sloping. And See, actually, without that, if you did flip it, if you did make it H comma P, whatever you will get will anyways not be one of the answers, I think. So this is the only way you could do it. Okay. Any other questions from week 4? Let's first talk about week 4. No other questions from week 4? Okay, so there was, I think, um, some error in one of the questions, question 9 or something. So there was a misprint in the previously there was a misprint, but after the answers were published, the question changed, and I think the um, answer was different before. So, there's some basic problem. There's some system problem. So I think they will not consider this question in the grading. So if you got it wrong, please don't worry about it. It's not going to affect your score in the end because it's a problem in the question. But I think a lot of people are starting to have a lot of doubts about many questions. Like not every question is wrong. So I mean, I saw a whole bunch of questions in the discussion forum about other questions. So all other questions are correct. So for this was like an obvious thing where they asked about coffee when they said you can't consume any coffee, something like that. So that's like very obviously either wrong or like the answer is already there. So that is a very obvious thing. But in some other questions, sometimes they are just trick questions. You should always consider the possibility that the question is just a trick question. It's not necessarily like a wrong question. Okay, so let me share this week's questions, what I have prepared. Yeah. So this is, we're going to discuss a fair bit about preferences and utility today. And I think we discussed it before also, but today we'll discuss it in a whole lot more detail. So firstly, does everybody understand what is reflexivity, transitivity, and completeness? Because these are the most important properties, right, of preferences, the axioms of rationality. So any problem in definition of these properties? Because if there's no problem, I'll go ahead with the questions. But if you're not like very clear on these properties, then the questions will become confusing very quickly. Okay, so if there's no problem with it, then let's go ahead. And just by the way, my internet usually disconnects after a few minutes. I don't know why. There's some issue with this internet. So in case that happens, please just stay on and I will join back as soon as the internet comes back again. It usually does reconnect again in like 5-10 minutes. Okay, so somebody is asking for me to give a recap. Let's take a very quick recap. In week 5, we studied the axioms of rationality. And the first is reflexivity. We generally don't talk too much about it because when we talk about completeness, it kind of includes reflexivity already. The reflexivity means that each item in a set, say suppose there's a set and it comprises elements like apple, orange, guava, pineapple, which other fruit, banana. Okay, this is a set. I'm purposely not taking numbers because people get very confused with numbers very, very quickly. Because in numbers, you already have an idea in your head about what greater than, lesser than, bigger than, smaller than mean. But we're not talking about bigger and smaller in terms of relations. So in set theory, relations in set theory is an important part where, I mean, a set, first of all, is a collection of objects, right? So we can have any objects, and those objects, even if they are numbers, they don't necessarily imply that, just if you have numbers 1, 2, 3, 4, it doesn't necessarily mean that 4 is more preferred to 2. Right? That is the confusion which a lot of times people have. So I'm just taking it as this. If you want, you can shorten this to something like this. Thankfully, they're all different letters, so we can put it like this. And let's rename this to avoid confusion. So suppose this is a set. Reflexivity just means that each element is related to its own self, right? So it doesn't make any logical sense when we, when we say that um, each element is related to its own self. But we'll come to it a little bit later when I'm talking about completeness. Now, let's say we talk about transitivity. This you can say X is at least X is like the is as preferred to as X, something like that. In transitivity, what we are talking about is that if X is preferred to Y and Y is preferred to Z, then this implies that X is preferred to Z. So this sign is not the same as this greater than sign. This is, I think, something easy to confuse, especially because the symbol, when you're writing it with like handwriting, it looks very similar. So sometimes it looks like it's greater than symbol, but it's not the greater than symbol. It's a separate symbol in set theory, which means that this is preferred to, or in terms of that particular relation. So say suppose there is a relation we have defined the set on. It can be any relation. So in this relation can be is sweeter than, or can be is bigger than. It can be any kind of a relation, right? And in the context of that particular relation, which we have defined that set on, then X is preferred to Y and Y is preferred to Z. And preferred to in this case is not necessarily more than. Okay, it can be if it's a smaller fruit, for example, but the relation is as sweet as, is sweeter than, or as sweet as, then you could say something like, an apple can be as sweet as banana, right? Oh, sorry, as sweet as a banana, something like that. Right? Apple and banana may be very different in sizes. So I hope you understand the logic what we're talking about. So in this case, say suppose apple is, we're talking about sweetness, that is the relation we're talking about. Apple is as sweet as, or is at least is preferred to banana, not as sweet as, is preferred to banana. And say banana is, okay, I'm writing it wrong. Just very used to writing that symbol actually. Banana is preferred to, say, guava, then this implies that apple is preferred to guava. Okay, so this is, I'm talking about general set theory right now. I'm not talking about consumer preferences. So this is what transitivity means in general. Now, in terms of our consumer choices, we're talking about, when you're talking about relation, when you're talking about mapping and ranking, we're talking about consumers ranking and consumers preference over this whole set of consumption set. So when we talk about a set, the same set, say suppose the set, let's rewrite this set. It's A, O, G, P, and say B, just writing it in short. So in the case of consumer theory, consumer preferences, this is a consumption set we're talking about. And we're using some of the maths from basic set theory to represent what we're trying to say mathematically in mathematical notation. Instead of writing like 3 lines about it, we are just, or 1-2 lines about it, we are just writing A is more preferred to banana. So then let's talk about completeness. In completeness, what we mean is that each element has a ranking. So in this case, we have taken only single items, okay, apple, orange, guava, pineapple, banana. But it can be ordered pairs, it can be a combination, it can be, anything. Right? It can be a bundle. So there can be another set, say suppose, which is an ordered pair. Okay, it can be an ordered pair like this. Any kind of set, right? So this is one element of the set. Okay, let's see, put it like this. So this is one element, this is one element, this is one element of the set. So when we rank this, the second set S2, we are ranking A, B, B, G, and so on. When we are ranking here, we are ranking A, O, G, and so on. Is this making any sense, or are you getting more confused? I'm just trying to like expand on it a little bit. Is this making sense? Yes, no? You're not following? Making sense? Okay. So a set is a collection of objects or a collection of elements, and that elements can be single objects, single items, or they can be sort of ordered pairs or collections themselves. So like for example, like when we talk about a consumption set, we will generally have this set 2 kind of a scenario. Why? Because we are talking about two goods generally. Right now, if this is a case of n dimensional thing, like we're talking about n goods, then this S2 will very quickly become very complicated, and not complicated, but maybe at least not that simple. It will be something like A, B, C, D, B, C, D, F, whatever, combinations of four items or something, right? So we don't really discuss this. We don't really discuss this in economics because it's just unnecessarily complicated, which is why we stick to this two good world. So this S2 is usually the kind of scenario you will encounter in books or in questions and everywhere. But just for the sake of simplicity, I'm going to talk about this first scenario because it's just single good. So if there is a whole bunch of goods, bunch of items, because we're talking about consumption set right now, right? So in this, I deleted this. Yeah. So in this, for example, you have 5 fruits. What we're trying to say is that there is a ranking given to each item here. We are not leaving any item out from this particular set. Okay. So we are saying that, say suppose this is one of your preferences. Let me put my preferences for that matter. Say suppose I like pineapple is preferred to let's say apple. Right, apple is preferred to orange or guava. Let's put guava first. Guava is preferred to orange. I'm say indifferent between orange and banana. I'm not, but let's assume I am. Okay, so something like this is what we mean when somebody is asking me to change the language. So I'm speaking in English. You're free to have captions in whichever language is more comfortable for you. That's I've approved that. Okay, so like I was saying, when we say completeness, I'm talking about each element being given a rank, right? It should not, if I don't put this last preference, then banana does not have a rank, right? We don't know where banana fits into my whole preference, setting. We don't know whether I like banana more than apple or pineapple, or I like it less than guava. Where do we put banana? We don't know, right? So if tomorrow I have to make a choice between buying a banana and an apple, the economist will be like, we don't know. We can't say what she's going to choose because we don't know where she puts bananas in her list of preferences, right? So we can't really do anything for this particular problem because we don't know where it is ranking. We don't know what is the utility she derives from this particular fruit. So this is what we mean by completeness, that you cannot leave one element out without giving it a rank, right? Being indifferent to is a rank. That is important to remember. That say, suppose I'm indifferent between banana. Oh, I don't know why I'm writing it like this. Sorry. I'm and guava, or actually not preferred to say, suppose this is only indifferent. Say, suppose I'm just indifferent between banana and guava. That is also a relation because I've given it a ranking. I've ranked it as same as guava here. So the ranking will be what? If I put everything in a rank, pineapple, then apple, then guava, and banana is at the same rank as guava, then orange, and that's it, right? So we have ranked all 5 of them. There can be any number of items at one rank, but each has to have a rank, is what completeness means. So does this explain what what I'm trying to say? Now, obviously, when we are talking about putting it in a rank, then the moment you give a rank to an item, you are already giving it a relation. So it's sort of like that is what reflexivity is. It's not a very intuitive concept, so you don't have to worry too much about it because I don't think, at least at your level, you'll have any kind of questions where you need to check for reflexivity. If completeness is there, then completeness is inclusive of reflexivity. Completeness means you are giving a rank to each item, so obviously then you can do that only if that item is already related to itself. Okay, so let's come back to the question we had. Now let's do this question. So now I think it should hopefully be simple. Now, can somebody answer this? What will be the answer here? You can take a minute to read it. In these preference relation questions, it's always better to write down the preference in that notation and then put it in a rank, like how I was doing. So, because it's very difficult to sort of keep all that ranking in your head sometimes, it kind of becomes a bit too much. This is a very simple question, but otherwise, it's just better to write it down. So, what is the deal here? What are we not? What are we missing? Which axiom is violated? Problem? I didn't see anybody posting an answer. So let's write this down. So what is he saying? Melon is better than orange, right? Apple is better than melon. Apple is preferred to melon is what the person is trying to say. And then he says orange is preferred to apple, right? So what is happening here? Let's put it in a rank. Melon comes first. Melon is preferred to orange. Apple and melon, which one is preferred? Apple. So it's apple first, then melon. And orange is coming before apple and also after melon. So it's coming here also and it's coming here also. So what is happening? Let's do this again. I think this is the part where we got confused. So melon is better than orange, right? So melon is on top, orange is in the bottom. And apple, next one, apple is better than melon. So apple is on the top above melon. Now the third part is saying that orange is better than apple. So orange is going above also. What is happening? Is this making sense? What is happening here? So what is happening is that orange is less than M also and more than A also, which cannot be possible if we are following all the axioms. So which axiom is this which is getting violated over here? First of all, reflexivity, is it followed here? Is everybody following reflexivity? Are all the items ranked or given some sort of a relation? They are, right? We have only three fruits, and there is each fruit has been given some sort of a preference criteria mapping, right? Let's talk about completeness. Yes, all the fruits have been given. Sorry, that's what I meant by completeness. What happens in transitivity? In transitivity, what we said was that if x is preferred to y and y is preferred to z, then this implies x is preferred to z. Can we say that here? I think people are not following. Either that or I'm not audible. Okay, there's an absolute silence, so I don't know if you're understanding or not. But basically, this is what is getting violated here. You see, we are saying that A is preferred to M and M is preferred to O, right? So that means A should be preferred to O, but it is the other way around here. So this is what is getting violated. This is the part that is getting violated. Okay, I hope it is clear. If it's not clear, please let me know. Otherwise, I'll move on to the next question. Should I move on? Okay, so since nobody is answering, I'm assuming. See, reflexivity, if you have satisfied completeness, the reflexivity is automatically satisfied. Okay, that's all I wanted you to understand. Is completeness satisfied here or not? Just answer that. Have we given a rank to each of melon, apple, and orange? Can we say that we have given a rank? In general set theory, X relates to Y implies no, it does not. I mean, it does not imply that. That is symmetry in set theory. What you're saying, X relates to Y implies Y relates to X is not true always. Because we are talking about the same relation, Y. There may be some relation between X and Y and X, but X relates to Y is equal to Y relates to X is only in the case of symmetry. It is not always true. Is that clear? Is that answering your question? I don't know what is your exact confusion, so I can't answer it unless I understand what your confusion is. Mm. You want to explain? Yes, X relates X is you. That's one way of writing it. You can also write it in the preference term. Like, don't get confused with the notation. You can use either notation if you find X relate to X, but you used capital X. That is not correct. X, let me write it here. What you're saying is that, say, suppose there is a relation. If there is a relation which is, defined on X, it's defined uh, on X, I think, like this, say, suppose, and X is, say, suppose, X, Y, Z, P, Q, something like that. Okay, just for the sake of simplicity, I'm giving a finite set here. Okay, then what reflexivity implies is X relates X, small x, not capital X. In this case, it should be generally true in consumer preferences. Yes, so that is an axiom of rationality for consumer preferences, right? That's what I'm trying to say, that this is what this belongs to X. That's what we're trying to say. X relates X is just another way of saying the same thing. And completeness, what we mean, I mean, if you want to write in that notation, for all X, you can say X relates Y belongs to X, something like that. Okay. All right. So let's go back to my question. So now, okay, only one person asked me the question, so at least he asked me so I can answer. If anybody else has not understood, please tell me in what way you have not understood, so I can answer. Otherwise, I'll assume that you have understood. Okay, now let's move on to the nature of indifference curves and utility. We'll come back to preferences also a little bit later, but now let's combine our knowledge of preferences and the utility function and indifference curves. And this is the question I want to spend some time on. So the simple question: Alicia likes ice creams and chocolate equally. So which of the following is likely to be her utility function? Now I'll give you a minute or two to think about it. That why are we, um, how are we going to arrive at the utility function based on what the question says? So just take 1 or 2 minutes to think about it, and then I'll discuss it. Okay, so any answers? You can post your answers in the chat. Nobody has answered. Okay, so I'm thinking that this part is not very clear. So what happens in the case of, uh, the second question is also related actually. So we'll come to the indifference curves also. So in the same um, space, you could also think about question 3, that uh, if this is the case where she likes chocolate and ice cream equally is the important thing, then what are her indifference curves going to be like? Now, this is all we know. Okay, there's not a whole lot given in the question. So let's go to question 2. This was all question 1, right? So in question 2, all we know is that Alicia likes ice cream and chocolate equally. Right. So Let's put chocolate here and ice cream here. Okay. Now, what happens in the case when somebody likes two goods equally? You like two things equally, meaning you can easily use one or the other, and it doesn't make a difference to you, right? Instead of ice cream, I can eat chocolate also. If instead of chocolate, I can eat ice cream also. My preferences are that I'm indifferent between the two. So then this is the case of what? That's a perfect substitute, right? When you like two goods, there's good one and good two, where we have taken chocolate as good one, ice cream as good two, and we are saying that she likes both of the goods equally, meaning we can substitute between both. So she's willing to give up 1 unit of good one for 1 unit of good two. That is what in economic terms it means when you say that a consumer likes the two goods equally, or the same amount, or prefers them the same. So this is a line of slope -1. So this is not exactly a line of slope -1, but this is sort of like what a line of slope -1 might look like. So this is kind of what happens in the case of perfect substitutes. Why? Because on this line, at any point, you can take, say, oops, you can take a small segment where, change over here by some quantity is change in this also by the same quantity, right? So this, if this is, say, suppose some quantity E, this is also E. So if you are reducing good 2 ice cream by E, you're gaining good C, good 2, sorry, good 1 by E also remaining at the same utility level. So this is, say, suppose U1 indifference curve. Similarly, you have U2 and so on and so forth. Your utility is increasing outward. So this arrow is very important. This arrow indicates in which direction your utility is increasing, right? Because utility could be defined in any way. It could be increasing in any direction. So if you are making an indifference curve, if you're drawing an indifference curve, please don't forget to put this arrow, because this arrow is what decides a lot of things about the indifference curve and about the nature of preferences. So I don't know, I'm going on talking. I just wanted to know if it is making sense to people. Is this clear? Is it making sense? Yes? Okay. All right. So what we mean by perfect substitutes, or when you like both items equally, is that you are okay with letting go of 1 unit of one item and gaining 1 unit of the other item without any change in your utility level. So if you remain at this utility level, this is a perfect substitute. And we know that in the case of perfect substitutes, their indifference curve is like this line of slope -1. Are you asking a question? You can't see the board. Okay. Is my screen visible to everybody?
Yes.
Okay. So Asif, I'm not sure why you're not able to see the board. Maybe you can log out and log in again. I don't know. I didn't do anything special actually. It's like what and how I normally, yeah, thank you, log out and log in again. Okay. So yeah, so we know that in the case of perfect substitutes, this is the kind of a line we will get, because this is the only scenario in which you can forgo one good and gain the other good constantly without, like, at some point on a curve you may get that, but when we're saying that as a general rule for somebody's preferences, constant slope of -1 or constant, uh, what we'll come to that MRS is -1, then you get a straight line like this. Okay, so this is what your indifference curves will be like. And what was the other question? Let me see what the question was. So now I think it is hopefully simpler to answer this question. So what which equation do you think will represent the utility function? Think in terms of the indifference curve now. Which equation is representing? So when we're talking about utility function, just understand that utility function is the equation of the indifference curves. Utility constant, say suppose we take this, all these as constant. Oops. If you take this as equal to constant k, that is the equation we're looking at. So this equation x plus y equal to k, or x under root x over y equal to k, or xy equal to k, is the equation of the indifference curve, where the value of k is different for each curve. So that is how you can read a utility function and map it to indifference curves. So now which equation do you think will represent her utility function? This is what we just discussed. You can type your answer in the chat box. Okay, one person has answered. Others? No other answers? We just drew the curves, right? We just drew the indifference curves. So which equation represents that? I think people are finding a little bit of difficulty in this part, indifference curves and utility functions. Okay, let's move to the third question. It's a similar question. So which this you can answer hopefully. Which is the correct answer in this question 3? What are her indifference curves like? Okay, one person has answered. Others? Okay, 2 more people have answered. Good. Okay, so this is an important aspect, it's a minor point, but in this situation, answer option A and D both are correct, because a line, this is a line, right? This is the equation of a line we are talking about. I'm not sure why you guys are getting confused about that. This is your indifference curve, and this is a line. So what we're looking at is the equation of a line. And when we're talking about a line, it can be considered as convex or concave. I'm talking in terms of function. As a set, I'm not talking about as a set, but when we're talking about convex to origin, we're talking about the shape of the curve basically. So the line has no curvature as such, so it can go both ways, like depending on how you have framed it. So even if this was the other way around, it would still work. And if you have said none of the above also, it is fine, because if you are confused because you are thinking that it's a straight line, so that is not given in the options. So that is, I mean, technically it is not correct, but just if I'm talking about your understanding level, then I think you're not exactly wrong, because many people don't know that a line is considered convex to the origin actually. So mathematically it is considered convex because basically it has no curvature, so it's not curving either way, right? It's not curving this way, nor is it curving that way, so we just assume it as either convex or not convex. Both are okay, both are correct in a sense. So which is why, like, if you have written none of the above also, I will consider it correct. I don't know if it will be considered correct in the exam or not, that I don't know, but your understanding is correct, is all I'm trying to say. So now I hope it's not too difficult to, what is the equation of this line, this pink line which I've drawn? What will be the equation of this line? It's not that difficult to do. Come on, this is, I think you understand this much now. So this is a simple line with a slope -1, right? So it's a line with a slope x plus y equal to k. Yes, finally somebody answered the correct option. Thank you. I was feeling like I'm talking to people, but I don't know why you're not understanding it. So are you comfortable with this now, that this is the slope of the line and hence this is, so when we are saying this, what we mean is that here the value of k is something, here the value of k is something else. Why? Because we are talking about constant utility. So x plus y equal to k is the equation of all of these lines, all of these indifference curves. Say suppose I draw one more here and I draw one more here. All of these are indifference curves for this person, right? And they all are of this type, this form, x plus y equal to k, where the value of k is different for each line, right? The pink value, pink curve, pink line, k is equal to something else. Say suppose k is equal to 5. Blue curve, k is equal to 10, maybe. The white curve, k is equal to 15, perhaps. Green curve, k is equal to 20 or 25. So all we know is that this arrow symbolizes that utility is increasing in that direction. So we know that, let me erase this thing. This is kind of, oops. Yes. So we know that, say, suppose this is U4, or instead of U4, I'm writing U4 so that it kind of goes in very firmly that we are talking about utility only. This K is nothing but utility. And this is U1. So all we know, this arrow implies that U4 is greater than U3, is greater than U2, is greater than U1. And what is all this? U1, U2, U3, U4 are nothing but different values of K. I know it's mathematically not like the simple, arithmetic algebra kind of maths we do, because this is combining a lot of economics intuition with some basic maths. It's not very complex maths, right? But it's that relation between the economic intuition and the maths which takes a little bit of time to settle in. But once it does, you will find it really simple yourself, right? So what I'm trying to say is that each of these lines has the equation x plus y equal to k. And for each of these lines, the value of k is different. And all we know is that this arrow is showing in which direction the value of k is increasing, right? And what is this value k? This value k is nothing but the level of utility which that person is at. So the person is at a certain level of utility at that, the pink line. Where you move anywhere along that pink line, the person's level of utility remains the same. Then you move to the blue line, and the level of utility is higher than what the person had at this pink line, but it remains the same all and at every point on this blue line, right? I hope it is making sense now. Now, the fact that this is a perfect substitute is why we have all these kind of curves in the first place as lines. But if, say, suppose it was not a perfect substitute case, even then, what you would have is some curve. I'm not writing the equation, it is some curve, some set of curves. These are your indifference curves. Okay, this is not very horizontal. Something like this. Okay, these are like your indifference curves, say suppose, and each of these has some function fx y is equal to k. And each of these is just different values of k for the same function. Say suppose it's x square plus y. It's not, but say suppose it is something like that, equal to k, where k is varying for each of these curves. Again, this is nothing but where fxy is nothing but ufxy. Utility is what we're talking about. So I think I've overdone this. I've explained it quite a fair bit. Hopefully you understand this. So let me move on. So now let's come back to this. So this is the correct answer. U of xy is x plus y equal to k. So the last, not last, C option, u is equal to xy is not a case of perfect substitutes. At some point on that curve, you may find that, you know, uh, you may find that the slope of the curve at that particular point is maybe -1, but it will not be true throughout the curve. So you have to keep that in mind. Okay, let's move on to question number 4. So again, bring little bit more clarity about the whole um, discussion on preferences. So now just read the question, take 2-3 minutes to read the question, then I'll discuss it. If you want, you can type in your answer in the chat box. So this is the diagram which is showing Molly's preferences over milk and cookies. And you have to tell me which of these statements is not true. Could be more than one also. So yeah. Okay, so some people have answered. Others, it's okay if you answer wrong. If you answer wrong, at least I know where you are misunderstanding something or where you have not understood something. So please don't be afraid of answering. There is no award, reward. You won't even get any extra marks for answering correctly in this class. So it is okay if you answer wrong occasionally or even all the time. That is the process of learning. So unfortunately, the process of learning involves being wrong a lot of times because that is how you learn. Nobody understands everything perfectly all the time. But at least you have to be willing to accept that you have not understood something perfectly so that you can understand it perfectly. We don't like that part of learning. We all always want to be correct, always want to understand everything, but that's not how it works. So okay, at least we have some more answers. Now let's see what what is happening here. So the most important thing to observe is, yeah. So most important thing to observe is this arrow first of all. Right? I'm making it bigger in case it wasn't obvious. So if somebody wants to change their answer, you can still do that. If you didn't pay attention to the arrow, because it's a bit small, maybe it wasn't obvious. But anyway, so what is happening here? What does the arrow show? I said that the arrow was showing the direction in which your utility is increasing, right? So now say suppose S say this is U3, this is U2, this is U1, then U3 is greater than U2 is greater than U1, right? So what is happening? If I take this point and this point on this curve and draw a line, say suppose, okay, this point, then the utility here is more than the utility at this point, right? And this is happening in the direction of increase of utility. So the preferences are convex actually. It is just that they are not, the shape of the curve is such that it is not how we are usually used to, but the preferences are convex because it is shaping like this in the direction of increase, right? So let me draw it here. Question, what is this question number? 4. So what we normally draw, let me look at this figure itself. We already have it here. So in this, we're talking about increasing in this direction, right? What we said about convexity is that there's this bundle. Say suppose there's this bundle A and this bundle B. Okay. And the consumption here is X1, Y1, here it is X2, Y2. What we are trying to say, what is the, for the moment, if you remove the X1, Y1, all we mean is that T times A plus 1 minus T times B is what? Is some point on this line, and it is belonging to your consumption set. Let's say it is S. That is what we meant by convexity. And the basic shape that we get is that this line is basically in the direction of increase. This is not like a mathematical, let me make it a bit clearly. It's getting very messy. So let's draw it like this. So this line is in the direction of this point. This line which is joining the two consumption bundles, consumption bundle A and consumption bundle B, the line joining those two consumption bundles is preferred more than just A or just B, right? This is higher. This point, any point on this line is ranked higher than, let me make it thicker so it's a bit clearer. So this is the indifference curve, right? With utility, say suppose equal to K. Okay. Now in utility is increasing in the direction of the arrow, right? So all of this region, this whole region, I think it's not that clear because my board is black, but this entire region above the indifference curve has higher utility, right? This whole, let's call this U1. This whole region is U greater than U1. That is what the arrow means, right? That is what indifference curves are showing. So this point we are talking about on this line is preferred more to any point on this curve. Is that not? That is what we are meaning by convexity, right? When we say that a balanced, a balanced consumption, like, some of good X and some of good Y together is preferred than just good X or just good Y. That is what usual definition. Okay, I'm sorry I got disconnected. I have no idea why. So I think the internet is back on. Let me, yeah, let me just, okay, I think most people have joined back. Okay, let's go back to where we were. Yes, so what I was saying, let me switch the background so this more easily visible. Right, so now you can hopefully see this blue shaded area. We can extend this curve a bit this way, a bit that way. Okay, so now you can hopefully at least understand a little bit visually that if I take this point, this yellow point, I'm marking a word here, it is a point on this line. I mean, draw this line in yellow. Okay, this yellow line is this line. It is this line, right? T times A plus 1 minus T times B. This is this line. And what convexity implies is that this bundle, any bundle on this line, is preferred to any bundle on this pink indifference curve. Like that, what we are basically saying, I mean, there is an entire video in which Professor Vimal has explained this very rigorously in terms of set theory. I'm not spending too much time on that because that proof is already there. You can refer to it if you want. All I'm trying to say is that you have to be careful about in which direction this arrow is pointing. This arrow is very important. If arrow is pointing in this direction, then this preference set of preferences are convex. But if this arrow were pointing in this direction, then this particular set of indifference curves are not convex, because what we are saying is that if the utility is increasing in this direction, in the blue arrow direction, then that point on that yellow point on the line, the yellow line, is less preferred to compared with any point on the pink curve, right? And that is not convexity, that is the opposite of convexity. So hopefully if you have understood what I'm trying to say, then in this curve what we are doing is exactly the same. We have just sort of flipped it, right? We have just flipped the whole thing. And what we're saying is that it's not xy, let's put the actual, what did we, this is what, where is milk, where is cookies? Yes, so cookies is on the x-axis, milk is on the y-axis, right? Now if utilities, and this is origin, so if utility is increasing in the direction towards origin, what does it mean? The lesser you're consuming of milk and lesser you're consuming of cookies, the happier you are, right? Maybe you are a special person who has like, no great liking for milk or cookies, right? So in this case, because this is the case, consuming less and less of these two goods makes you more and more happy. So like a lot of children don't like it, right? A lot of kids really do not like drinking milk and really do not like, some kids at least don't like cookies perhaps. So it could be some such case. I didn't like milk when I was a kid. So jokes apart, all I'm trying to say is that this, for this particular individual, right? We're not saying that this is a generic scenario. This particular individual, this is how the preferences are. They're increasing as you decrease the amount of each good. So obviously, what we have is that, what's the question saying? Option B, no, let's come to option C. C says an increase in consumption of milk and cookies increases our happiness, but that is not the case. What we are seeing is that if you increase milk and cookies, your happiness is actually decreasing. If you see, if you're somewhere here and here, which is like maybe a good, say suppose you're at here at some point, then your utility is U1. And yeah, if you're here somewhere, if your utility is say U2, and then there is origin, but let's take one more point before the origin. Here somewhere, your utility, this point is U3, right? What we're saying is U3 is greater than U2 is greater than U1, right? So that means that higher milk and cookies gives you lower utility. I hope this much has become clear. So what now? We just draw this line and see what is happening here. You see this point, any point on this line, maybe let's make it red. No, not many colors left. So any point here is preferred to higher than any point on this curve. Let me use some other color. Okay, if I use this color for this curve, then any point on the pink line is gives you higher utility than any point on the blue curve. Okay, I think we've spent good amount of time on this. Is this still confusing or is this clear? So the preferences are convex. And what was the other question? There was some other statements in this. Yes, so preferences are convex is correct. Molly likes both milk and cookies equally. Is that correct? Do you think that is correct? So now in this case, we've already just seen in the previous question that when you like both the goods equally, your curve, indifference curve is going to be a straight line. And typically with slope equal to -1. So if she did like both the goods equally, then her indifference curves would be something like this. And because the utility is increasing towards origin, just the arrow will reverse. Okay, this may have been a point of question in your mind. The arrow is going to be opposite, the curve is going to be the same if she liked both equally. She does not like both equally given the current scenario. Okay. Okay, let's move on. All right. C we already discussed. D prefers a combination of milk and cookies to only milk and cookies. So that is correct, right? Because that is exactly what convexity implies. And we can see that that is the case here, a combination of, like you can see in this, sorry, on this whole diagram where I've drawn that blue line, a point on that blue line has higher utility than a point on that curve for U3. So D is correct. So what all is not correct? B is not correct and C is not correct. So I think some people had posted the correct answer. So at least I think you have got it right. I'm anybody else who did not get it right. I hope it is clear now. Any doubts you can tell me. We will spend some more time if you still not understood. I just don't know if you've not understood. So any questions? No questions? Okay, then we will go to the next question. So in this, and there's no option to choose, but I've just drawn this empty skeleton for XY axis. We are just going to take pizza on the Y axis, and so she's, and so there's, suppose there's a place where you can buy both pizza and Coke, and Rachel likes pizza but she hates Coke. Consuming pizza makes her happier, whereas consuming Coke makes her unhappy. So what can we say about her preferences? Right, so I'll give you 2 minutes to think, and then if you have drawn it somewhere, you can just post the picture on the chat. I will just look at your diagram. There's an option to send a file on the Zoom chat. So you can do that. You can send the file on the Zoom chat if you want. I'll just mute myself for 2 minutes. You can think and answer in the chat. This is a slightly tricky question, but I'm just spending a little bit of time on all of these different preference relations. So you are kind of solid on the fundamentals. Because a lot of people have a lot of trouble with just this, just drawing the indifference curves. And that's common. There's a lot of confusion around it. I'm not sure what you mean. Durga, I think you posted your answer, but I didn't understand what you mean.
Ma'am, I mean that it will be exactly on the x-axis, maybe.
Okay, so what is happening here? First, let's discuss that. What is exactly happening here? I will open this diagram in a bit. What we are told is that increasing P is increasing her utility, right? And increasing coke is decreasing her utility, right? So combine this and this. I mean, you can just do vector addition. What happens? This is the direction in increase of her utility. That's just basic common sense I'm talking about right now. So we know that utility is increasing in this direction, and I'm decreasing this part. Sorry, deleting this part. So what happens now? Let's draw the curve and see how it should be shaped. Now, if I increase pizza in this direction, my utility is increasing. But if I go up, my utility is decreasing, right? Utility is decreasing in the up direction. Till now, what we were doing was we were drawing curves which were sort of um, either both the goods were either both the goods were goods or both the goods were bads. That's the kind of scenario we were talking about. Isn't that so? Either the person liked both the goods or the person disliked both the goods. So we had a very simple scenario. Now in this scenario, we know that there is one good and one what in economics terms what we call as bad. So let me draw it in a slightly better way here. This is question number 5, right? Okay. So this is pizza and this is Coke. And like I said, this is the direction of increase of utility with pizza, and this is the direction of increase of utility for Coke. Increasing Coke decreases utility, so increases pointing downwards. So the direction of increase of utility is in this direction, right? So if it is in this direction, generally what happens? Generally, the indifference curves are actually drawn orthogonal to the direction of increase. So they're going to be something like this. What I'm talking about is just geometrically. Geometrically, the direction of increase is like this, then indifference curve is orthogonal to that, right? I don't know if you understood. I'll just repeat it if you didn't understand. This is the direction of increase of utility, right? Let me make these arrows also in this color. So this is direction of increase, at least that's how I've sort of mapped it in my head. The thick pink arrow is the direction of increase of utility. So if I number this as U1, U2, U3, U4. What we are saying is U4 is greater than U3 is greater than U2 is greater than U1. So the curve is kind of perpendicular to the direction of the arrow. That's how it always is, right? That is what geometrically it means. If the utility is constant along the curve, then that means that the curve is perpendicular to the direction of increase in utility, right? So if you are able to get the direction of increase in utility, you can always plot the the nature of the curve. Is this making sense? I mean, I'm speaking everything geometrically right now, just so you have a little bit of some guideline or some thumb rule on how to draw indifference curves. Is this making sense? Or is this confusing
Okay,
you?
ma'am. Okay. Right,
Got
ma'am.
it? Okay. So what we have now talked about is this is pizza, this is Coke, right? So in this case, it so happens that we have put pizza on the x-axis and Coke on the y-axis. So you're getting the curves like this. But if you just flip it, you know, if you just flip it, then again, don't try to mug it up. Just think about the same thing again. So suppose pizza is here and Coke is here, right? So utility is increasing where? If pizza is increasing, utility is increasing. Coke is decreasing in utility is increasing, right? So direction of increase of utility is here, right? So again, you're actually in this particular case, you're getting the diagram as almost the same, but it is just the arrow is pointing in the other direction. But it may not happen for every case which you are given. So just be careful about which is on which axis, right? Okay. So now in this case, let's come back to this case. This is your indifference curve. It is a straight line. We're assuming it as a straight line for now, just for the sake of simplicity. It because there's nothing else given. All we know is that she just completely hates Coke and completely loves pizza, right? If there is no sort of how you say, there's no room for nuance, right? If there was some room for nuance, it could have been something like this, like this. All of these show same kind of relationship, but this is like, where she may not hate Coke so much. She may be like, okay, a little bit of Coke is okay, not so much. But because our case is given like it's a flat thing, that is why we get something like this. So uh, building on that same thought, the equation of this line will be what? Something like y is equal to, x plus k or something like that, right? um, this is the line through the origins. This is y is equal to x, and the others k may be plus or positive or negative or whatever, right? So this is something you can oops, sorry. So let's not put this as k, because when we say k, we generally mean positive constant. Let's say this is c. This is a generic general equation for indifference curves is this. So if you are given a utility function of this sort, y minus x plus c, where c may be positive, negative, whatever, right? Then we can say that this is the equation of the case where the consumer loves one good and hates the other good. One good is a good, the other is a bad. Right? I'm just trying to build on that thought, so you start thinking in those terms. You start reading the utility curve to utility function to understand what the curve will look like, and hence what the preferences will look like. Because I think you people have understood utility function separately, indifference curve separately, and preferences separately. But that part where you kind of stitch all the three together is still work in progress. So every time you look at some set of, you know given some set of preferences, think about how will you draw those preferences. Like, what we were given was just that she hates one thing and she loves another thing. So in that case, we know how the utility is going to behave, and so based on that, we drew the indifference curves. Now that we have seen what the indifference curves looks like, we can estimate, or we can guess or think about, just based on geometry, that the equation looks something like this. The equation looks something like this, and obviously the utility function is going to be something like this. So conversely, if you get some question in which you have a utility function like this, then that means this is the kind of a situation you are in. So this is not in the question which I have given, but I'm just trying to help build your thinking about these types of questions where you are given a function and some person asks you, is this a case of perfect complements? Is this a case of perfect substitutes? Blah blah blah. Things like that. Okay, coming back. Now let's complete this diagram at least. So this is, something like this. Okay. And actually, I'll erase this because when somebody reads this question, I don't want them to see all the answers right away. So just for those of you who have not, attended previous classes, who are not familiar with it, I upload all my slides and class notes to Google Drive. And let me once again share that link with you. Give me a moment. It's there in that tracking sheet, which is linked on the Swayam portal also, but I'm just sharing it anyway, because I think many people kind of don't see that very easily. So I'm just putting it on the chat, the folder link once again. So in this folder, I have been uploading all the class slides and class notes and everything. And yeah, so all the solutions as well as the questions, everything is there. I upload it after the class because I upload whatever we discuss in the class also. So I'll upload these slides and the notes after the class. If you need to, you can refer to it later also. It's for you. I'm not restricting anybody's access to it. Okay, so now we come back to another question on preferences, which is a very similar question to what we had in question number 1. So I will take a 5-minute break now, and I'm leaving you with this question. Spend some time on it, think over it, and post your answer in the chat box. Tell me which one it is. I'll just be back in 5 minutes. I've been speaking for 1.5 hours. So let me just drink some water and I'll be back. Okay, so let's come back to question 6. So nobody has posted their answer. So how do we start? It's okay if you don't have the answer. Can you tell me how we go about such a question? Actually, Professor Vimal took an example very much like this in the class. So this is it's not an entirely new question or concept. I'm just writing down the same question here, or what is given in the question here. It's question number 6. You're given a consumption set A comma B, B comma C, A comma C, B comma D, and D comma A. Okay, and you are asked to assume A, B, C, D, they all belong to positive real numbers. Okay, and what we know about the preferences of the consumer is this. We know that AB is at least as preferred as BC, BC, sorry, BC is less preferred to AC, BD and DA is indifferent, D comma A is strictly preferred to A comma C, and B comma C strictly preferred to D comma A. Okay, so whenever you're given something like this, what you want to do is you want to put them on a rank. Okay, somebody has answered. Okay, let me open the question. Okay, I think at least somebody got the answer correct. So it looks a bit complex, it looks a bit confusing perhaps, but first let's see how do you check for completeness. You check for completeness just by checking if every element in this set, C is the set, has every element been given a preference relation at all or not. Is AB there? Yes, AB is here. BC is there. This is BC. And we have another relation relating BC. A comma C, you have A comma C. B comma D, you have B comma D. D comma A, there. So all items in the consumption set have been given some sort of a relation, right? Whether that relation is, whether that relation is logically rational or not, we don't know yet. But they have been given a relation, right? Okay, so that means what? Completeness is satisfied because every element has a rank. You can order these based on that. Every element has been given a preference relation. If they was say suppose another element in this, just suppose there was another element D comma C, and the preferences were given as what you're given, then the axiom of completeness would be violated, right? If D comma C belongs to consumption set C, then completeness is violated, right? However, there is no such D comma C in the consumption set C given in the question. So we will ignore this. I'm just trying to help you understand what each violation actually means, right? Now, reflexivity, again, like I said, I've put there again as a red herring. It's not something you need to worry about because, again, if completeness is satisfied, then reflexivity is automatically satisfied. And because each element is at least as preferable to its own self. It sounds logically very funny when we talk about it, like at least linguistically it sounds very funny, but mathematically that is what it that is what it means. That is always satisfied, or there are very few cases where it is not satisfied. So that leaves us with transitivity. So just by process of elimination, you can probably guess transitivity, but there is an option, none of the above also, I think. Yeah, no axiom is violated. So we can't be sure. It's still possible that maybe transitivity is not violated. Let's check. So now to check for transitivity, what you will do is you will see every relation, every preference, and you will try to put each element on a rank, like on a ladder, right? Something like that. And try to order each one of them. And if the ordering is, there's no problem with ordering it, then we are fine. Then transitivity is satisfied. But if some element is at the bottom of the ladder also and at the top of the ladder also, then we know that this is a case of cyclical preferences or a case of violation of the axiom of transitivity. So that we cannot, that we cannot allow in rational preferences. So let's do that. So A comma B is at the top. Then you have B comma C is below it. Now the second says what? According to second, B comma C is less than A comma C. So A comma C is somewhere here. It could be same as A comma B, or it could be less than, or it could be more than, but it is above B comma C, right? We don't know about between A comma B and A comma C yet. Okay. Then between B comma D and D comma A, we know that they are at the same level. So they're at the same level. Okay. For now, I'm putting it here. Let's see where it goes. Now we know D comma A is greater than A comma C. So D comma A will come here. Let me, okay, let's fit it in here only. And because B comma D is at the same rank, we are putting that also here. Right? Why? Because it is given that it is D comma A is higher than A comma C, which is A comma C. And at the same time, we are given B comma C is higher than D comma A, meaning D comma A is lower than B comma C. Now, can both of these things be possible at the same time? This and this. They can't be, because according to this, D comma A is greater than B comma C, right? What we know is D comma A is preferred to A comma C, which is preferred, at least as preferred to as B comma C, right? Whereas here, what we are getting is B comma C is greater than D comma A. This is what transitivity is saying, but this is violating transitivity. Both of these cannot be true at the same time. B comma C cannot be more preferred to D comma A and less preferred to B comma C, right? Sorry, D comma A. Is that making sense? And see, actually, I should not put this here because this is strictly, if there was an indifferent sign, we could have taken that, the person is indifferent between the two. But the last relation says that B comma C is strictly more preferable than D comma A. So then these two cannot be satisfied at the same time. Therefore, transitivity is violated. So is this clear? Is it making sense to you now? Everyone who did not answer, any questions? Okay, so just try to, practice these type of things. This is not the type of maths we normally do, which is why it does not feel very intuitive at first. But just think, don't get scared that thinking this is something very complex. It's actually not at all complex. It's just common sense. We are saying something is liked more, by somebody than you like coffee more than tea, and you like tea more than milk. Then we are just saying that you will obviously like coffee more than milk, right? Then you cannot also say that you like milk more than coffee. In reality, that may be so, but in like what we call as Homo economicus, that is not true. We don't study Homo sapiens, we study Homo economicus. It's like a kind of like a joke in the world of economics. So by Homo economicus, we're just basically referring to the kind of what we call as rational, um, rational behavior or rational preferences. Okay, somebody's asking if D comma C is there, then why completeness is violated? Because we have not given any relation for D comma C. Okay, so if D comma C is there, then there needs to be some relation for it in this. There is no preference mentioned for D comma C in this list, right? So if there is nothing mentioned about D comma C, about whether you like it more than something, you like it less than something, nothing is given, then how can you decide whether somebody will when somebody will choose D comma C and when they will not choose it? Completeness means that each element in that particular set is given some preference ranking or some preference relation. Okay, all right. Okay, so let's move to the next question then. So this is another interesting question. So I'll again give you 2 minutes to think, and then we have only one more question after this, and then we'll wind up. This is an easy question, actually, not very difficult if you understand the logic of it. So, what is the answer? Okay, so what is this question really talking about? What it is saying is that there are two utility functions of two people. There are two goods, A and B. And one person's utility function is u A comma B. And the other person's utility function is u square plus alpha, where alpha is some positive parameter. Okay, so now what happens in this case? What are we doing to you? What is this thing called, what we are doing here? Question 7, right? So you are given u and v is nothing but u A comma B square plus alpha. So we discussed something about ordering of ordering of utility. So if you know different values of, this is basically what the utility function tells you, that if some consumption bundle x1 y1 is more preferred to x2 y2, then u of x1 y1 is greater than u of x2 y2, right? So utility function basically gives a mathematical relation or mathematical expression to your preferences, but it is not a cardinal number, it's an ordinal number. This is there in the lectures, and what that means is that the only the ordering of the utility values matters, not the exact value. So if, say, suppose I'm using some function u xy is equal to x plus y, right? Or let's not take xy, let's say I'm saying ux of y is equal to xy, okay, x into y, that means, right? Oops, it's fine, leave it yellow. Then the ranking of this, say suppose x1 is equal to 1, y1 is equal to 2, x1 is equal to 2, y1 is equal to 4, x1 is equal to 3, y1 is equal to 5, something like that. What is going to happen? Or sorry, for all of these we are getting some values of utility, right? What happens? So you say suppose u1 is equal to what? 1 into 2, 2, u2 is equal to 2 into 4, 8, u3 is equal to what? 5 into 3, 15. What you are getting is a gradation or an ordering of utility values for different consumption bundles. X1, Y1, X2, Y2 is different values of consumption for good 1 and good 2. And you can see that this is increasing. Now, if there is another utility function, say suppose there is a function V for the same consumption goods, X, Y, which is XY whole square. And we try to calculate V for the same values of X1 and Y1. Then V1 is what? 1 into 2 square, which is 4. V2 is 2 into 4 square, 64. V3 is 3 into 5 whole square. 15 square is, I think, 225, right? So values have obviously changed, but is there any difference in ranking between U1, U2, U3 and V1, V2, V3? Is the ordering the same or is it different? I'm expecting an
Same.
answer.
It's same.
Same, right? Yes. So that is what we're trying to say. Say suppose now I define another utility function w of xy, which is okay, let me write it a bit neatly. Xy whole square plus 1. Sorry, xy whole square. Read it properly. Say suppose x is xy whole square plus 1. And we calculate this. W1 is what? 4 plus 1, 5. W2 is what? 64 plus 1, 65. W3 is what? 22, 25 plus 1, 226. Again, is there any difference in the ranking between U1, U2, U3, V1, V2, V3, and W1, W2, W3? Values are again different, but the ranking ordering is the same, right? All we're concerned with is the ordering. What is the order of the utility values? Is W, all we know, what we know is that, sorry, is that W3 is greater than W2 is greater than W1, and V2 is, sorry, V3 is greater than V2 is greater than V1, and U3 is greater than U2 is greater than U1. That's what I mean by ordering. The ordering is the same for all three functions. Yes? Any problem in this part? Somebody unmuted themselves. Are you asking something? Okay, if you're not asking a question, I will just request you to please mute yourself. Otherwise, I get an echo. So, what we are trying to say is that the ordering of the consumption bundles is the same. Ordering of the utility is the same, whether the function is xy or xy whole square or xy whole square plus 1. So that is exactly what the question is asking. The question is not asking anything very different. This, you can just write this as u xy whole square, right? What is u? U is xy. You can write this as u of xy whole square plus 1, isn't it? And instead of this 1, whether it is 1 or 5 or 10, but it doesn't make any difference as long as it is some sort of a constant, right? So that is exactly your question. If you read the question in the beginning, what is given? U is given to you, A, B, and V is given as u square, u whole square plus alpha, where alpha is greater than 0. So now we have, you can take any numbers you like. Instead of x1, x2, you can take a, b, or which you can rephrase it or reframe it whichever way you like. Basically, what we are saying is that this is the result. And what this is, I've not used a technical term right now, but this is what we refer to as a monotonic transformation. A monotonic transformation does not change the basic ordering of the values of the function for any of the input variables, right? So if you have variables x, y, and the function is u is a function of x and y, different values of x and y, and you do any kind of a monotonic transformation on u, then whatever resulted function you get, say suppose u square or even log u, there are many such monotonic transformations, but these are the ones you will typically encounter very, very commonly. So it's like, if you're not disproportionately changing one variable, like here in this case, x and y both were squared and a constant was added to that whole square itself, right? You're not adding x back into it. You're not adding y back into it. You're not, multiplying one by one number and the other by other number or something like that, right? That's what I'm trying to say. I'm just trying to explain what a monotonic transformation is and is not. So if you do something like xy whole square plus x, this is no longer a monotonic transformation, right? Because your disproportion, x is a variable, it's not a constant, right? So the values of u, of v equals to this and u equal to xy is not going to be necessarily the same for different values of x and y, right? Because here you're adding x back to it, which is a variable. So this is not a monotonic transformation. Let me put it in some other color. Not monotonic. So that mathematical relation, that if g of u or g of f is the transformation, then g prime is greater than 0 is how you will typically test for it. But I'm just trying to help you develop an intuition for it, what we mean by monotonic transformation. Like the example I think Professor Vimal gave in the class was that of a rubber band. If you stretch it, I mean, the values are changing, but the ordering of different points on the rubber band remains the same, right? So that is what we are trying to do here. So hopefully, I think this question is clear to everybody now. Any problems with this question? So the answer is that the ranking, ordering of consumption bundles or preferences, whatever you want to call it, for John and Sherlock are the same. Okay. Now let's go to the last question. This is again not very complicated, but you will need to think a little bit, I guess. So actually we have two more questions. I forgot that there was one more question. Okay, we'll be almost out of time. So I will leave these two questions for you. You can solve it. And because this is also slightly, it's not actually complex, but it is I think maybe better discussed in the next session, because this type of questions have not been discussed in week 5 yet. But question 9 you can probably do, because you've not discussed MRS. But it will take me at least 15 minutes to explain question 9, and I have a cold. So I think it is just better if I answer it in the next class. So is that okay? I think whatever we discussed today should be sufficient for you to answer questions in your assignment. Is that okay if we discuss? I want you to also attempt it properly. Otherwise, if you do it in a hurry, you will not have enough time to think over it. And then we will rush through it and it may not even be very clear to you. So question 8 and question 9, please attempt it on your own. I'm leaving these 2 questions for now. I thought I will be able to cover it actually, but it's okay. So I will solve these 2 questions first thing in the next class. And in the meantime, please think over it and attempt it on your own. Okay. And in the meantime, if you have any other conceptual doubts or questions, you can post it in the discussion forum. Okay, so let's end it here. And yeah, stop the screen share. Yes, so if there is any other doubt you have in the discussion forum, please post it in the discussion forum. You can post it ahead of the class, so I can maybe bring something interesting or some rephrase, or phrase some question around your doubt to answer it in the class. It just helps me prepare a little bit better. I mean, if you ask a question, I can of course answer it, but I can expand on it a whole lot better if I have another question prepared which is related to that particular concept. So I guess that's it for today. Anything else you want to mention or ask or whatever? No. Okay, so I'll see you guys next week, and please do attempt those questions. It will help you clear your concepts around MRS. All right, I'll see you guys next week. Thank you.
Thank you.